Another reason why it's ugly to be working with memory that you allocate on the heap using the new operator is because the variables and objects that you allocate on the heap are pretty much like global variables. If you remember, I spoke about global variables in a different video and why they are so ugly to be working with, because since they are accessible and changeable by anyone and everywhere, whatever level of scope you may be, then we can easily lose track of who's making what changes to what global variable, etc., etc. And the situation is similar with variables that you create on the heap. Of course, not everyone could right away access this memory. The only way to access this memory, these variables and this stuff on the heap, is only if you have the pointer, the memory address where this variable is located. But any scope or function which does get the memory address because you passed the pointer in or something like that, then again we pretty much have the same effect of any function and any scope that has the pointer to this place in memory. Anyone can control this variable and do whatever they'd like to it. And even though you would like these other levels of scope and functions and stuff like that to actually manipulate this variable, the worst part of it all is when you have to keep track of who is really in charge of this variable right now and who is supposed to delete it when we are done using with it. We don't want to run into such a situation where one function is already done using this variable, so that function will go ahead and delete that variable on the heap, but we forgot that a different function in a different scope is still relying upon that variable still existing in the heap memory and still has a pointer to that variable in memory, and it will try to dereference and use that variable which apparently no longer exists because a different function deleted it. So as you're passing the pointer to the stuff that you put in heap memory, as you're passing it around from one function to a different function to another function, and different classes and different methods and functions each have another copy of this pointer, you're going to have to keep track of who is really in charge of the pointer, who still needs it and who doesn't need it anymore. When am I supposed to really delete it? Are we okay now? Is anyone else going to be using this variable a little later on? Is it safe to delete it now? Maybe someone else still needs the variable. Now, let me make something clear. There's no such thing as this horrible, terrible feature in C++ that is so terribly dangerous that it should never be used. So from today on, I am never ever going to use the new and the delete keyword. There's no such thing. Everything has its place in the right time. You too will come across the need to use the new operator and the delete operator sometime in your C++ programming. You probably will not be able to avoid it all your life. And for good reason. It is a very useful thing. It was put into C++ for a reason. The only point I'm trying to teach you is that when the situation does come up that you do have to use this feature of allocating memory on the heap and then deleting the memory, don't forget to keep in mind all the rules and all of the dangers and issues involved with doing such a thing. And there is pretty much a solution for most of the problems that I've been talking about until now. For now, let's start with one very important ingredient in C++, which helps with a lot of the issues about the variable being vulnerable for anyone to access. One very easy way to control the access, or basically the possibility to change a variable or a pointer, is of course by using the constant keyword. We haven't spoken about this for a while, and it's time to bring it up, that it's important that you get into the habit of using the const keyword as much as possible. So first of all, the reason why we generally use the constant keyword is because we are trying to stick to the rules of object-oriented programming, where different variables and different functions belong to certain different packages and logical way of grouping stuff. Unlike, let's say, a global variable which anyone and everyone could access anytime, in object-oriented programming, we try to group together different functions and variables which belong to a certain separation of stuff. And so, in other words, we want to keep groups separated that only something that belongs to this particular group will be accessible and changeable by only this group. However, we do not wish anyone else outside of the group to have access and to change around variables and functions of another group. Just to give you the idea, let's say I have a class called a bank, which has a whole bunch of variables that belongs to it, and I have a different class, company, which has a whole bunch of other variables inside of it. So just like in the real world, everybody minds their own business, the company cannot possibly access the variables and the private stuff belonging to the bank, and the bank doesn't have any way to access all the private stuff of the company. That's one of the major ideas of object-oriented programming. Everything is packaged up in separate groupings which initially don't know about each other and don't access each other. Yet, of course, it would really be totally useless if they had absolutely no way of communicating between each other. A bank needs some information about the company, and the company needs to know information about the bank. At some point they do have to communicate between each other and ask each other for different information, etc., etc. And that's another aspect in object-oriented programming, and that is about how different classes, different groupings of variables, how are they supposed to communicate between each other, so to speak. And also, how are you, the programmer, supposed to be accessing individual classes? Like, how are you supposed to be accessing the stuff inside of bank and the stuff inside of company? According to object-oriented programming, the way this is supposed to be done is by making classes offer an interface with which outside entities can access this particular class. The interface of a class is usually its public members. The public methods and public variables that you create in a class are the way we access this class and communicate with it to find out information about this class, about the variables that it has, and the values that these variables have. Most of the time you will be making all of the data, all of the variables of information that a class has, you will be making that private. That is the private information of this particular class, which no one else should be able to access. It belongs to this class. Only this class can access it. So in our example of the class bank, let's say if you make a variable like the amount of money that the bank has, or what is its stock value, that would be the private information of the bank, which of course you would not like anyone else to access any time. The only way anyone could possibly communicate with an instance of this bank class is through its public interface, which means any of the stuff that you declare public in the class, such as this public function right over here, as I explained all about this in a different video. The point I am getting at about the constant keyword is that sometimes when your class will be supplying information, maybe even some of the private information of this particular instance of the class, like maybe you'll make a function which will return the actual amount money, like this variable right over here, you would want to make sure that this information stays intact and that the private variables of this class will not be changed in any way. If you ever used Windows or Mac or whatever, something like that, you've probably heard something about different files and folders which can be either fully accessible and changeable or read-only. Sometimes you want to protect a certain file or folder that people should be able to open it and read it, but people shouldn't be able to change stuff inside of that folder or file. Same thing when you're handing out information about your class, like a specific private variable or something. You always want to protect and make sure that your variable your private variable stays intact and unchanged.